1 over n squared is a constant term, so we can factor it out of the sum. We have the summation from 1 to n of I plus 1 over n squared. We're going to factor out 1 over n squared, and we get 1 over n squared times the sum from 1 to n of I plus 1. We're going to write that sum as the sum of I plus the sum of 1, of course, from 1 to n. Now, the sum of I is a formula. The sum of I from 1 to n is n times n plus 1 over 2. 1 is a constant. The sum of a constant is C is Cn, so it's n times 1. Between the brackets, we're going to distribute n, so it's going to be n squared plus n over 2. That is for the first term, plus the common denominator is 2, and n is 2n over 2. 1 over n squared times, we're going to combine the numerators, n squared plus n plus 2n, 3n over 2. Which is really 1 over n squared times, when we factor out n times n plus 3 over 2. And n over n squared is 1 over n. So we get n plus 3, and n times 2 is 2n. n plus 3 over 2n. So this is the formula for the sum. For n equal to 10, we're just going to replace, we're going to call it the sum, Sn, we're going to call it the sum to avoid writing the sigma symbol. So it's going to be 10 plus 3 over 2 times 10, which is 13 over 20, or as a decimal, 0.65. When n is equal to 100, the sum Sn, according to the formula, will be 100 plus 3 over 2 times 100, which is 103 over 200, or 0.515. When n is equal to 1,000, Sn, which is the sum, will be equal to 1,000 plus 3 over 2 times 1,000, which is 1,003 over 2,000, or 0.5015. And finally, when x is equal to 10,000, the sum will be 10,000 plus 3 over 2 times 10,000, which is 10,003 over 20,000, or 0.50015. Notice that when n is extremely big, the limit of the sum of I plus 1 over n squared as n approaches infinity will be n, the leading term of the numerator, over 2n, the leading term of the denominator, which is 1/2.